So today, make sure that you've numbered this 18. Make sure you've numbered this 18 so it goes in the correct place in our note section. When we're defining the variable, again, it says that's the first thing we need to do, but I like to go ahead and let's label. Let's do some work with this first. Remember, you got to write something or else you might not know where to start. So when I look at the very first part of the sentence, we're translating it. We're changing it into math. The first word is 7. Can I change 7 into math? Yeah, all I'm going to do is write the number. So there we go. There's the number 7. That was easy to make math. Okay. Let's look at the next word. The next word says decreased. How could I change decreased to math? Caleb? It's subtraction. So if I'm decreasing something, I'm making it smaller, I'm taking something away, we're subtracting. All right, so it says 7, which now is the number, decreased, which is now minus, by a number. Does it tell me what number? No, so what can I use for that? Nick? Huh? We can use n for number, which is called a variable. We can use a variable. So I'm going to put n, which equals a number. So n just stands for a number. Do I know what number? No, that's why I have a variable. They're awesome. They can hold the place of anything. So up above that, I'm going to put the letter n because that's what took its place, correct? So now if I look up here, it says 7 minus n. Well, that looks like a pretty good math sentence to me. We just want to double check. Is there anything in that sentence that would mean I need to switch it around or move things at all? Now, what's the word I'm looking for that tells me to move stuff? Luke? Than. This does not say anything about less than or more than or fewer than. So it stays exactly like that. It said 7 minus n, so I'm going to write 7 minus n. Right? Now guys, these are a little bit easier than the ones you did for your homework because I had a lot of students that were having some trouble with that, so I thought, okay, let's take it down a notch. Let's just talk about a number. Tomorrow, we're going to step it back up, okay? All right, so let's look at number 2. Again, before I even start doing this, I'm going to change what I know. All right, 9. Do I know how to change that into math? Yeah, it's the number 9. Because again, guys, we're translating. We're taking these English words and we're changing it into the language of math. All right, then it says more than. More than. What does that mean mathematically, Brian? Okay, than is going to insinuate that these are going to have to switch. But right now I'm not worried about that. What does it mean mathematically? More than. So that's talking about the grammar behind the math. All right, we're not getting into grammar yet. We're just getting into, like, if you will, the words of math, which are numbers and symbols. What does more than mean mathematically? Abby Faith? That we're adding. So more than is where we get our plus sign. All right, do y'all see how right now I'm literally, like my vocabulary in math are numbers and symbols. All right, my vocabulary in English are the words. So I'm taking the words, changing it to numbers and symbols. All right, twice. What does the word twice mean? What does the word twice mean? Ledger? 2. 2 what? 2 times. The word twice means something has happened 2 times. Well, mathematically, times means multiplication, correct? So twice means 2 times, and I'm putting my time symbol right there. Now, my final answer, can I put that time symbol? No. No, but for right now, it's good to know, hey, that's multiplication. Let's make sure we know that. All right, and then it says a number. Do we know what number? No. No. So what do we use in this case? Chloe? No. An n. We use a variable. Guys, if you wanted to use x, you could use x. X and n are the most popular when we're just talking about a generic number. All right, so we'll use n equals a number. And I'm going to put an n above that. All right, so now this says 9 plus 2 times n. All right, but we still have to address what Brian mentioned, and that it said the word than, which means we've got to switch these around. All right. Now, guys, here's the thing. Than goes with more, correct? It's more than. What operation is more than talking about? The addition. Guys, the only thing that can move is the numbers around the addition sign. The than has nothing to do with the 2 and the n. The than rotates everything around that addition sign. So think about like drawing a big circle and making it rotate, like turning a wheel, all right? So this 9, when I turn it, is going to move to the back, correct? So I'm going to go ahead and put my plus sign down here. So there's my plus sign. See, right in the middle, right where it was. My 9, we just said, has to move to the back because it's 9 more than something. So we're going to add 9 to something. All right, so the 9 moved to the back. Now that means everything over here is going to move to the front. So what was written over here? 2 times n? How do I actually want to write 2 times n though? Haley? 2n. So instead of writing 2 with that x multiplication symbol, we're just going to smush those together and put 2n. So my final answer here is 2n plus 9. All right? This is the challenging part because I had more than one operation. So it's more than just moving stuff around. I mean, more than just getting things in the right place. We also had to keep track of my addition, and we had to keep track of my multiplication. Are there any questions about 1 or 2? Any questions about 1 or 2? All right. I'm going to pause our recording because the next thing we're going to do is check our homework. Okay, so let me see. So, guys, we're starting back with our vocabulary. This is going to be on the same page that we did our number 18 on. So this was our math workshop that we just did. All right, and copied down. So we're going to put our vocabulary at the bottom of that. So I'm going to give you a moment to get those first 3 copied down. I'm going to pause our recording while you copy those. All right, so it looks like some of us have this first part copied down, so I'm going to go ahead and talk about this a little bit. Algebra. Yesterday we mentioned that it was a language because when we were translating it, we used the word translate because I'm literally taking the English language and changing it into a math language. And that's all algebra is. It's a mathematical language where we don't just have numbers and operations, we also have symbols, which include those variables that we've been mentioning. All right, we defined variable yesterday. We said it can be a letter or a symbol to represent a number. We're not going to be using these symbols. We're just going to stick to letters. You will see those in some later math classes as you progress. Okay. Number 3 was algebraic expression. An algebraic expression is a math sentence, all right, containing variables and numbers. All right, there's number 2 again. Please make sure while you're eating we're still writing. All right. An algebraic expression is a math sentence containing a combination of variables, numbers, and at least one operation. So, for example, if I had the math sentence 2 plus 7. 2 plus 7 is a math sentence, but it's not algebraic because it does not contain a variable. In fact, 2 plus 7 would be called a numeric expression because it just has numbers. Algebraic comes in when we bring in those variables as well as our numbers and operations. Okay. All right, coefficient, we mentioned this yesterday as well. It's the number in front of a variable. What operation do I have a coefficient with? Braxton? Multiplication, because if a number and a variable are right next to each other, we know that that is multiplication. Number 5. Number 5 is a word we're going to be using today in a slightly different context. All right. Evaluate here says to find the value of an algebraic expression by replacing the variables with numbers. Guys, we're going to evaluate numeric expressions today, which means are you going to have any variables? No, they're just going to have numbers. Guys, when it says evaluate, kind of my key thing that you should be doing is you know that that means you're going to have to work it out. All right, if it says to evaluate, you're going to work out the problem. That's really what that translates to. All right, I'm going to move it back up a little bit. Are we good with that now? Do we still need number 2? No. Okay. All right, that's fine. Number 6, okay. All right, number 6 is a term. A term is each part of an algebraic expression separated by an operation or a sign. All right, we're going to talk more about terms next week, and we're going to add another vocabulary word that kind of includes that. For right now, what we need to know about a term is, like, if I have 5x plus 3, that's one term, and then that is one term. So that's two terms, and that's an algebraic expression. I could even have on here plus xy. Now how many terms is it? 3. Now, please don't be confused. Those are two different letters, but is there a plus or a minus sign separating them? Is there an operation symbol separating that x and y? No. So that's 1, 2, 3 terms. That would still just count as one thing. Okay. I'm going to pause it again while we finish. All right. So at this point, if you did not get to finish copying that, we should have had plenty of time. If not, that will be sent out on Remind tonight. You can also copy it from one of your friends in Warrior Time, okay? Today we're talking about order of operations. All right, this should be a review from your 5th grade standards. Order of operations, does order matter? Clearly, because it's the order that you do your operations in. All right, guys, here's the thing. You have these awesome, wonderful scientific calculators. Does that mean you can type everything in and magically go, poof, here's my answer? No, I still need to see the order that you're doing your operations, okay? That's literally what this says. So you can't just give me, poof, a magic number. You've got to do them in order. All right? Just a reminder, remember, PEMDAS, or please excuse my dear Aunt Sally, stands for parentheses, exponents, multiplication, division, addition, subtraction. All right? A better way to write PEMDAS instead of just straight down would be parentheses, exponents, multiplication, and division. I'm going to group those together. Why would I group those together?
Because whichever one is there comes first.
Yes, you do this from left to right. You don't just do multiplication first and then division. You do them from left to right, whichever one comes first in the problem. And it's the same thing with addition and subtraction. Once you get all of that gone, when you do addition and subtraction, it is also from left to right. All right? So we're going to look at number 1 first. Are there any parentheses on number 1? No. Are there any exponents on number 1? No. Is there any multiplication and division? Yes, I have this division symbol and I have this multiplication symbol. Now guys, please remember, just because m comes first, does that mean we multiply? No. In fact, we're going to go whichever one was first in the problem. Which one was first in the problem? The division. So guys, I like to circle what I'm doing so when people look back, they can tell what's going on. All I'm going to do is 18 divided by 2 right now. What does 18 divided by 2 give me? 9. Have I done anything else in this problem? No. So I still have my 14. I still have my addition. I still have my times 18. And I still have minus 7. The only thing I did was 18 divided by 2. All right. Now what operation am I going to do, Caleb? Multiplication. Because we still have that multiplying and dividing comes before adding and subtracting. So 14 plus, what's 9 times 18? Nick? 162. And then we still have minus 7. All right, now what operation am I going to do? We're down to addition and subtraction. Nick? Addition. Am I doing it because this A was first? No, I'm doing it because the plus sign was first. All right, what's 14 plus 62 going to give me? 178. 178. And then we have minus 7. All right, so that should give me my...
176.
Just kidding. 176. I can do math sometimes. 176. Thank you. Way to be on top of things, guys. All right, so 176 minus 7, that should give us our final answer, which is, Nick? 169. 169. Okay. Good little refresher. All right, let's flip it over. Let's flip it over real quick because there are some harder problems on the back, more challenging. All right. I want us to look at number 21. So down here at the bottom, we're going to look at number 21 together. All right, number 21. Order of operations starts with P. What does that P stand for? Parentheses. P stands for parentheses. So we've got to start there. In this first set of parentheses, 6 plus 4, what does that give me? 10. So I have 10. All right, what was outside the parentheses? The small 2, an exponent of 2. So we've got to keep that exponent there. Have I done anything with it yet? No. So it stays. Plus, guys, since these parentheses are completely separate, we can go ahead and start working these in the same step. All right? This has multiple operations. What operation is going to come first? The division. All right? So I have 11 plus 5 now, because that 10 divided by 2 gave me 5. All right? That's the only operation I did in there. All right? Have I gotten rid of my parentheses yet?
No, ma'am.
Nope. So we still got to finish my parentheses. So we have 10 to the second power. That's how you would read that exponent. 11 plus 5, what does that give me? 16, okay? Am I ready to add yet? No, my parentheses are gone. The next letter is E for? Exponent. So guys, I know that's an exponent, but does anyone remember, how does that exponent work? Lester? You do 10 times 10. What if instead of a 2, that was a 3? We would have another times 10 there. We would do it 3 times. If it was a 5, we would have 10 times 10 times 10 times 10 times. The exponent just tells me how many times to do it. So 10 to the second power, 10 times 10 gives me 100 plus 16. Next.
Someone taught me like the exponent on tens. So it's like if you had a 5, it'd be 5 zeros. If you had a 2, it'd be 2 zeros.
Yes.
That's what I remember.
That's fine. That's awesome. All right. All right. Any questions about our homework for tonight? Okay. So here's the good news. You only have to do the even.
The what?
The even. Okay.
So why do we do that? Why do we do 1?
I'm not doing your homework for you
Wait, so do we cross
because I'm not doing your homework for you.
cross out all the odds?
You can cross out all the odds. And you notice the problems that I did were odd because I'm not doing your homework for you, but it gave you an idea of how to do your homework. Alright? So you only have to do the even.
For each other,